Hello students, welcome back. We went through first two problems here. Now the third problem here, they look kind of similar. Previously we had only one base, 7, and it turned out to be a quadratic equation of 7. Not too difficult actually. Once you see that this is quadratic and this middle one, x plus first power is actually 7 times 7 to the x power, then you can do this kind of thing without too much trouble from that point on. The first step is hard. Next, 9 to the x power, that's quadratic, and 3 to the x plus 2 power you can decompose as 3 squared times 3 to the x power like this. And 3 squared is 9, so yes, you can factor further. Factorization, and we have two candidates. Turns out both of them are solutions. How about this one? Similar. This is quadratic. 2 squared. Now how do you take care of this x plus first power, x plus second power? X plus first power, you can take this 4 out, 4 to the first power out. X plus 2 power, this 2 squared out. So we have 4, that's also 4, as you see down here. And 4 to the x power, that's quadratic. And this is linear term. So what we have here, we have a quadratic equation of 2 to the x power. You can factor it, assuming you know how to factor. Yeah, you have these. And then from the first factor, we have one solution. From the second factor, we have another solution. You should immediately see the first solution is impossible. Exponential is never negative, so that's impossible. From the second one, we have the solution. We get x equals 2 log base 2 of 3/2. Or you can use natural logarithm. Take the natural log of both sides and use your log rule. Take x outside and remove this ln to the other side. You can work out like that too, but taking this log base 2, this is a little bit easier way. Okay, that was a quick review, and let's go to logarithmic equation. First problem is pretty much straightforward because we have just same base and we have just a log rule to apply. So from this original problem here, do you have any coefficients to work with? No, not really. So all you have to do here is just to combine just two logarithms. Is everything okay? We have log plus log, so log of multiplication. Okay, all right. We can remove this logarithm by taking appropriate power. And what is that appropriate power? When we had ln, we took e to whatever power, but the space is 5, so we have 5 to whatever power. So 5 to this log base 5 of 2x minus 1 x plus 2 there is equal to 5 to the second power. And this exponential and logarithm cancel each other out. That's the design. They're inverse functions of each other. So they just go out. And what do we have? We have a quadratic equation. Right hand side, 5 squared. That's coming from base 5 and this 2. So that's 25. We have, let's see, left hand side is 2x squared plus 4 minus 3 plus 3x minus 2 equals 25. 5 squared is 25, 2x squared plus 3x minus 27 is equal to 0. I hope my computation is correct. And then 9 times 3 is 27. So we have 2x plus 9x minus 3 equal to 0, isn't it? 9 times -3 is -27. So that's plus 9 minus 6. Yeah, that'll do it. -9/2 or x equals to 3. Now, if you plug in x equal to 3, everything will be okay. We have 3 plus 2 here, so we have log of 5. So log base 5 of 5, that's 1. Plug in x equal to 3 over here, and then another 5. 6 minus 1, so log base 5 of 5, that's 1. So 1 plus 1 is equal to 2, all good. So this one is going to be good. But this one you can immediately see this is out because this is very negative. And then put it here, and then you're going to get a negative number inside the logarithm. So it's actually an easy check. Let's see, what did I do here in this answer key? Okay, combine those logarithms and then take exponential 5 to this logarithm, and then logarithm and this exponential cancel out, and the right hand side 5 squared is 25. Solving the quadratic equation, we get all those. Yes, we went through those, and then plugging those back into the original equation, we have illegitimate and legitimate solutions. So x equal to 3 only. Okay, we have one more problem here. We have two different bases, but they are related. I can change this into log base 3 by taking the change of base formula like this. So remember, change of base formula here. Oh, I see. This is for natural log of natural log, but in this case, I can use another base b to change that. Log base b of top, log base b of down. So log upstairs, log downstairs. Up is up, down is down. It's not too deep. And then let's go ahead. Log base 3 of 2x plus 5 minus log base 3 of x plus 2. And then what is log base 3 of 9? So that's log base 3 of 3 squared. You see, 9 is 3 squared. And then you have cancellation. Oh, never mind. Let me expand the font. So here, 9 is 3 squared. And then you have cancellation. Log base 3 and 3 squared. So you just have 2. And then the resulting equation here, you end up with a log equation here with denominator. Okay. Log base 3, 2x plus 5 multiplying by 2. And then multiplying by 2, we lose that denominator there. X plus 2 equals to 2 by removing the denominators. Okay, remove the coefficient. And then finally we have log minus log. Okay, finally we are ready. Combine those into a single logarithm, log base 3 of this 2x plus 5, those quantities squared, over x plus 2. That's equals to 2. Oh boy, what a work. The change of base formula here, that was used to get everything into the same base 3. Once you get into the same base, well, we still had some more work to do, moving this coefficient to the power, getting this complete square, and then the log rule, log minus log, so we have this fraction. Let's remove this logarithm finally by taking appropriate exponential, 3 to whatever power, so we have 2x plus 5 total quantity squared over x plus 2 is 3 to the second power. So the numerator is, I need a little bit bigger font, I guess, 4x squared plus 2 times 5 times 20, 20x plus 25 x plus 2 is equal to 9. And oh boy, we have this quadratic equation to solve. And then appropriate factorization and okay, all right. It's tedious, so I'll stop here. Instead, I'll just go to the answer key here and then just go from there. All right. Change of base, log base 3 of 9 is 2 because 9 is 3 squared. So we end up with this equation. We went through that already. Combine the logs into a single logarithm. We have this fraction. These two logarithms into a single logarithm. And then take exponential, 3 to the second power, so we have 9. And solve the algebraic equation, which turns out to be a quadratic equation. Take the like terms together, we get the standard form. You can factor it further, we get these two candidates of solutions. Always remember to check your answers. Looks like both are legitimate solutions. Here, I just plugged everything back into the calculator here and turned out yes, equal to 1. Down here, I used mental math, but calculator would have worked just fine. Okay, that completed everything. So if you have arbitrary bases, especially if you have some change of bases, things can get really rough. As for exponential equations, yes, it can get rough, but only to a certain degree. For logarithmic equations, it can be really tedious. Okay, so much for exponential equations. There are more examples in the textbook and more exercise problems in my math lab. For now, this will have to do.